Hey guys, y'all just finished watching a lesson on how to use your entire periodic table to do electron configuration, and we worked out an example for lead. Okay, so we're going to do one more that's a really lengthy element, and then I'm going to teach you how to do the shortcut. Okay, so let's erase lead. We already did that one. And let's move on to another one. Let's see, which one are we going to do? Typically I would ask y'all this, but nobody's here today. So let's try, I don't know, let's do Einsteinium, number 99, okay? So ES 99. All right, so this time I remembered I'm going to ask y'all to pause this and try this on your own before I do this for you. Okay, so pause the video. We'll see if you get it right. Okay, so I'm going to go ahead and work this out. So our first stop, remember we go in atomic number sequence. We've got 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. By the way, if this is going too fast for you, then you need to go back and rewatch a previous video, because I just want to make this very efficient for those that have caught on. Okay, so after 4p6 we have 5s2, 4d10, 5p6, and then after 5p6 we're going to go to 6s2. Okay, after 6s2, don't forget you have to go down to the F block. So then it's 4f14. Okay, that ends at element number 70, so then you will continue with number 71 in this section. Go to the end, so that's 5d10, and then 6p6. All right, we're almost done. I told you this was going to be like a marathon one. 7s2. And then our element is finally in this section, so we stop at row 5. Remember, it's not a row, it's the energy level. 5f11. Now, let's check to see if we did this right. If we did this correctly, we're adding up our exponents. So this is 4, 10, 12, 18, 20, 36, 38. Remember, I'm going to do my math a little easier. So after 38, I'm going to go to 40, 56, 60, 70, 86, 88, 89, 99. Okay, we're good. So that's the correct configuration. Now, you're not going to want to do this every time. And I told you, I'll only give you one on like a quiz or a test. So how do we do this a shortcut way? Well, here's how we do this the shortcut way. Okay, so first of all, I need to tell you that you need to write this in your notes. Okay, this is called the noble gas configuration. So for your noble gas configuration, you are basically just doing a shortcut for your electron configuration. Okay, it's a shortcut. Well, where do you think you're going to start if it's a shortcut and you don't have to do the whole thing? Well, let's look at the name. The name says noble gas configuration. You're going to start at the nearest noble gas without going past it. Okay? And then you're going to do the regular electron configuration from there. So if you need to pause this video and copy this down, then do that. And that's exactly what we're going to do here. So instead of writing all this out, which hopefully you remembered to copy in your notes, not on this periodic table, we're now going to do the shortcut. First of all, we need to mark on our periodic table where those noble gases are. I will not let you label the columns of each of these elements in order to know what to call these, because that's going to be some future test questions. So what I'm going to want you to do is, let me go ahead and erase this, okay? Let me erase that. Now, what I'm going to want you to do with a bright highlighter, okay, if you don't have a highlighter, you can do what I'm doing, which is just outlining, but we've got to highlight where the noble gases are. I already told you that they're over here in this column. Now, noble gases also include our little friend helium that didn't know where it needed to be, so it's kind of like disconnected. And it's not because helium's light and it floats. That would be a great reason, but it's not. So we are going to highlight this entire thing, okay? You can't put a label up here that says noble gases, but we're going to highlight this, all right? Again, mine's going to look a little weird because if I actually try to draw over it, we see nothing. It's not transparent, it's opaque. So that's where our noble gases are. These become our new starting points. So the cool thing about this is now if I get asked you to do Einsteinium, here's what we write. Okay, so our starting point is no longer hydrogen. Our starting point is the nearest noble gas without going past our element. Einsteinium is number 99. Which noble gas comes just before 99? It's going to be right here at number 86. Okay, so we have to write down where we start. We do that by making brackets and writing the element symbol for radon. Okay, and then in addition to that, I'm going to ask you to write the atomic number underneath that. So that's number 86. And now we do the regular configuration from that point. So after number 86, the next section is going to be at 7, row 7. So that's going to be 7s2. And we have to go down here, 5f11. So now that we don't have everything written out, can you still check to see if you did this correctly? Yes, this is still foolproof. So once you start with the nearest noble gas, you're then going to take its atomic number and add it to the exponents. So 86 plus 2 is 88, plus 1 more is 89, and then plus 10 is 99. So this is still foolproof, okay? So this is great. Let's try some more examples, okay? Make sure this was copied in your notes, not on your periodic table. Okay, so I'm going to do another example. I'm actually going to do a couple of examples. Whoops. All right, so let's see, which ones can we do? Let's try to do nitrogen, number 7, okay? Oh, by the way, I can already hear you thinking, can I just do this every time? This is so much easier. No, you can't. I will let you know when you need to do the long way, which is the electron configuration, and when to do the shortcut, which is the noble gas configuration. So yes, I'm gonna let you do this, but not when you choose, when I ask you to. Okay, so you need to remember which one's which. Well, when you take a quiz later next week, I am going to make it really clear, okay, well this is the shortcut. I'm going to call it noble gas configuration, but in parentheses it's going to say shortcut, so you know that that's the one that's shorter. Okay? All right. So we're going to try nitrogen, we're going to try krypton, and then we'll do one more under that. Let's do, oh, I don't know. We already did Einsteinium. Let's do, I don't think we did lead, so let's try lead. Okay? So we'll do lead, number 82. Okay, so nitrogen, it's right here. Oops, I totally circled that, and I don't want to do that yet. So nitrogen is right here. What noble gas do we start with? Well, which noble gas can we use without going past it? Without going past it. If you try neon, you're already at atomic number 10, and when you check yourself, it's going to be way higher than element number 7. Okay, so you can't use neon. What else is a noble gas? This guy right here. And we're going to start with helium. Okay, so remember, helium has to be written down in brackets. That's our new starting point. Its atomic number is 2. All right, and then our configuration just for the row it's on is 2s2 and then 2p3. Okay, going to check ourselves. So 2 plus 2 is 4 plus 3 is 7. That equals our atomic number. Yay, we're done. I'm going to do krypton last. Okay, now let's try lead. So lead is down here, element number 82. Okay, so there we are. What noble gas do we use without going past number 82? Number 54. Okay, it has to be from this column. Some kids, they miss that. Okay, so it's got to be out of this column. It's not the row it's on, it's one row above. So we're going to do xenon, Xe. It might look like a C on your paper because the copies aren't amazing resolution, but it's Xe, number 54. Then our configuration is 6s2. And then watch yourself, you got to go to the F section, 4f14, okay? And then 5d10. And then finally, 6p2. Okay? Should have had you try this before I did it for you, but that's okay. You're still learning. We've only done a couple of examples. All right? Now we get to krypton, and you might be thinking, oh, snap, what do I do? Could this be that easy? Or is this like, oh, okay, now I got to start at argon, and no, guess what? A noble gas configuration can be itself. So for krypton, it is its own noble gas configuration, all right? And that's element number 36. That's all you do, okay? So that is noble gas configuration. Make sure these are copied in your notes, and I will give you some practice work to do.